Hey, what's up guys, welcome back to another tutorial on machine learning, and in today's tutorial we are going to code Perceptron using Python and NumPy. So let's get started. So first I'm going to import NumPy, so I'm going to say import NumPy as np. Okay, so let's take a look at how Perceptron works again. So first, in the Perceptron we provided some kind of inputs, and those inputs are then multiplied by their weights, and after multiplying all those weights with the inputs or the resulting inputs are added together along with the bias value. So next, after adding all those, we pass it to our threshold function, and threshold function returns us some kind of a value. Okay, so let's try to do that using Python. So first I'm going to create a class called Perceptron. So I'm going to say class, then Perceptron, and inside there I'm going to pass an object. So I'm going to return the object of the class to itself, so that's why I'm passing the object over here. So next I'm going to create a initializer. So I'm going to say define underscore underscore init underscore underscore, and inside there I'm going to pass first of all self, and then I'm going to pass the eta or the learning rate. So I'm going to say eta is equals to 0.5. so I'm saying 0.5 over here. Well, that's because I don't want the user to get any error in case they forget to enter these values. So I'm going to provide my own default values so that user doesn't have any problem while working with this code. So next I'm going to pass for the number of iteration I want it to run for. So I'm going to say iter, and then I'm going to say is equals to 20. So I'm going to set it equal to 20 by default, and the reason that I'm using this underscore over here is that because iter in Python is a keyword and we cannot use keywords as our variable names. So next I'm going to say self dot eta is equals to eta, and self dot iter is equals to iter. Then we need to declare our weight. So I'm going to say self dot w is equals to a empty list, and then I need to declare my bias value. So I'm going to say self dot bias, and we can set the bias to be equal to a random value, or you can just set it equal to 0. So I'm going to set it equal to 0. Okay, so now we have initialized all our variables that are required. So next what we are going to do is we are going to create the two functions that are used to calculate everything in Perceptron. So the first one is the summation. So what I'm going to do is I'm going to say def then summation, and inside there I'm going to pass the input that I'm going to get. So I'm going to say x, and then what I'm going to do is I'm going to say y is equals to, y is going to be my output, or the output that I get after adding all those values or all those inputs after multiplying them with their weights. So I'm going to say np dot dot, and np dot dot will multiply my two matrices or my two arrays. So inside there I'm going to pass my inputs and the weights that I want to multiply it with. So I'm going to say self dot w, and then I'm going to add my bias value. So I'm going to say self dot bias, and then this function will return my output, that is y. Now this y can be a single value, or it can be a list of values, or you can say a array of values. Okay, so the next function I'm going to create is called the predict function. So what predict function will do is it will take the input from the summation function and apply the threshold function on my out, and then it will return the new outputs. So I'm going to say predict, and inside there I'm going to pass my inputs, that is x. So what this function does is it first gives the inputs to summation. So I'm going to say return np dot where. So first I need to pass all my values to the summation function so that I can calculate their summation. So I'm going to say self dot summation, and inside there I'm going to pass the value of x, that is my inputs. So this summation will return me some kind of output. So what I will do is I will check if that output is greater than or equal to 0. If it is greater than or equal to 0, then I will return 1. Otherwise I will return 0. So what np.where does is it checks if this condition is true. If this condition is true, then it will return the second parameter, or otherwise it will return the third parameter. Okay, so now that our summation and the predict functions are ready, we need a function that will train our model. So I'm going to say define train, and inside there I'm going to pass two values, that is my input value and my target, that is going to be y. Okay, so remember that we set our weights equals to a empty array. Well, that's because our x can be of any form, so we don't know what will be the shape of our x. So I'm going to now define self.w. So what I'm going to do is I'm going to say self.w is equals to np.zeros. You can always use some kind of a random values, but I'm setting it equal to 0. And even if you are using random values, it won't make much of a difference. The only difference will be that you might or might not take longer than me to actually reach to your solution. So what I'm going to do is inside there I'm going to say shape. Now the shape is going to be equal to x dot shape 1. And I'm saying 1 over here because my x will be a set of inputs and I only want it to be equal to the shape of my input. So inside the input it will have more than one element, so I will be passing more than one elements to my perceptron. So that's why I'm setting it equal to x dot shape 1 and not equal to 0. So next we need to create a variable called epoch, and it is going to track on which epoch we are on currently. So I'm going to say epoch is equals to 1 because by default in the starting will be at epoch 1. So next we are going to cover some iterations. So we are going to train our model on some epochs. So I'm going to say for underscore, and I'm saying underscore over here because I don't care about the iteration, or I don't want to store my iteration. So I'm just giving it some random variable that is underscore. Since underscore is a valid variable name, it doesn't complain in Python. So I'm going to say for underscore in range self.iter. Okay, so inside there I need to define a variable called flag. So why am I defining a flag? Well, I want to know when my model has been trained. So if my flag is equal to 0 at the end of an epoch, then I will break out of this loop or this iteration, and I will return my object and the training will stop over here. So I need to know when my model has been trained completely, so I'm declaring a flag so that I can track that process. So next I'm going to say for input comma target. I need to change the input to something else, so I'm going to say inputs because input is by default a keyword, or input is actually a function. So I'm going to say inputs comma targets. So for inputs and targets in zip x comma y, that is my input and my targets. So the reason that I'm using zip over here is that because I want to traverse both of them, and the length of both these arrays or numpy arrays is the same, and so I'm using zip. What zip does is it basically combines your two arrays together, so it is like you can say you are zipping your two arrays together. So next I'm going to call the predict function. So I'm going to pass my inputs to the predict function. So I'm going to say predicted output is equals to self.predict. I'm using self because we are inside a class and this function is also a member of a class. So I'm going to say self.predict, and inside the predict function I need to pass my input. So I'm going to say inputs, and this will return me my result or my predicted output. So next we need to find out the error. So I'm going to say error is equals to the target values. So targets minus the predicted output. The predicted output. Okay, so next step is to check whether my error is equals to 0 or not. And if it is equals to 0, then I will just go to the next input. Otherwise, I will update my weights. So what I'm going to do is I'm going to check if my error is equals to 0. So if error is equals to 0, then I will set my flag is equals to 1, because I'm using the flag to track whether my model has been trained or not, and if there is error, then that means that my model is not yet fully trained. So I'm going to say flag is equals to 1, and then I'm going to update my weight. So I'm going to say self dot w plus equals to. So the formula for updating the weight is that you need to have the old weight, then you need to add eta times the error times the input into it. So I'm going to say self dot weight plus equals to, that is basically like saying self dot weight is equals to self dot weight plus. So next is eta, that is my learning rate. So I'm going to say self dot eta times my error times my input. So inputs. Okay, so next I need to update my bias value. So I'm going to say self dot bias plus equals to self dot eta times the error. Okay, so now I need to update my epoch, and I need to update that epoch once I have traversed this loop over here. So I'm going to say epoch over here plus equals to 1. That will add 1 to my current epoch. So next, once I have traversed throughout my entire epoch, I need to check if the flag is equals to 0 or if flag is equals to 1. So if flag is equals to 0, if it is equals to 0, that means my my model is trained and there was no error. So I can just return my object. So I can return my trained object for this class. So I'm going to say return self. Okay, so we also need to know on which epoch we are currently on. So I'm going to say print, and this is going to be f string because I'm going to pass in a variable inside there, and I like using f strings a lot. And inside there I'm going to say epoch, and this will tell us on which what is the number of epochs that we have traversed until now. Then we can also print out the error. So I'm going to say print then error. Okay, so this is my perceptron, and now let's try and test it out. So I'm going to say ANN is equals to perceptron, and inside there I can pass the value of eta and the number of iterations I want to traverse. So that is totally up to me because I have already given the default values, but if I want to change these values, then I can also pass them through over here. So I can say 0.5 and let's set the iterations equals to 10. But this will only go till the 10th iteration if I don't return the object before it, or my model hasn't been trained before the 10th epoch. So next I'm going to run this. Okay, so now we need our input. So I'm going to say x is equals to, so let's train our model on the AND gate that we did in the last lecture. So I'm going to say np.array, and inside there I'm going to pass my values. So my values are equal to 0, 0, so that is my first input, and I have 3 more inputs. So the second one is 0, 1, third one is 1, 0, and the last one is 1, 1. Now I need to set my target values. So my target values are going to be equal to y is equals to np.array, and inside there I'm going to say 0, 0, 0, 1. Okay, so now we need to train our model. So I'm going to say ann.train, and inside there I'm going to pass the value of x and y. So I'm going to say x, y, and if I run this now, so let me check what is the error. Yeah, okay, so I need to put it equal to, not equal to 0. Well, that's because we only want to update our weights when we are not getting our error is equals to 0. And if we are getting our error is equals to 0, then there is no need to update our weights because our result is actually correct. So now if we run this again, and as you can see, it stopped at epoch number 6. And it's just like what happened in the last lecture. After epoch 5, we stopped at epoch 6. Okay, so now if you try to predict anything, so if you pass any of these 4 values, it will give you the right result. So I'm going to say ann.predict 0, 0, and it returned me the value equal to 0. So if I pass 0, 1, it is also equals to 0, and if I say 1, 1, and it is also equal to 0. So let's try to do the same thing for OR gate. So I'm going to change my target values equals to 1, 1, and 1. So if we run this now and I try to train my model, so it finished in 2 epochs. So that's because we already had trained them for 6 more epochs. So I'm going to run the entire code again, and as you can see, the epochs was 4. So in 4 epochs it trained for the OR gate. Now if I try to run this and pass 0, 1, it will return me 1, and if I pass 0, 0, it will return me 0. Okay, so you can also try for other gates, but remember that all those gates must be linearly solvable. So Perceptron can only solve those problems that can be solved using linear equations. So if you can solve something using a single line, or you can solve something by passing a single line through your data, then it can be solved using Perceptron. And in the future we will look at how we can solve those problems that are unsolvable using the Perceptron, or that are not linear or non-linear problems. So if you have any questions regarding Perceptron or any other topic that we did today, you can leave them in the comments below. And if you thought this video was helpful, you can like and subscribe. And if you want to be notified every time I drop a new video, you can turn on your notifications. Okay, I'll see you in the next tutorial.